Here we have two applications for composition of functions. So for this very first application, an employee is going to get an annual 3% bonus of any sales over $100,000. So we're going to be writing some equations to represent the scenario. The very first equation, or the very first part, is to write an equation to represent the sales over 100,000. So I'm going to call this f of x. So if the sales are over 100,000, we have to figure out how much they're over. So we would take how much they're over. Say they sold 150. So I would take 150 and subtract 100,000 from that in order to figure out how much over they are. For instance, if I plug in 150 for x, so say they had 150,000 in sales, we would have to subtract that from 100,000 to say that, hey, they sold an extra 50,000, right? So for part B, we are asked to write an equation to represent the bonus. So their bonus, I'll call that g of x, they get a 3% bonus. So 3% written as a decimal is 0.03. So they get 3% of whatever their sales are over 100,000. So if we want to write a composition to represent their total earnings, first we need to figure out what their overage is, right? For instance, it was 50,000 over for that one example. And then after that, we're going to take 3% of that. So essentially what we're doing is we're starting with f of x. We're trying to figure out how much over they are of 100,000. And then we're plugging that in to g of x. We're taking 3% of that. So if I take f of x, which is this entire function, and plug it in right here, that would be 0.03 times x minus 100,000. For this next scenario, we have a store that has 20% off for the day, and then someone might also have a $10 coupon. So for part A, we're going to represent an equation for the sale price. So if something is 20% off, then essentially you're going to be paying 80% of the price, right? So in order to represent the sale price, 80% would be 0.8. So that would be 0.8x. For the second part, write an equation to represent the coupon saving. So I'll call that g of x. So whatever the price is, you're going to be subtracting $10 from that because you have a $10 coupon. And then for this last part, we're going to be writing a composition to represent taking the sale price first and then the coupon discount after. So that means if I use our composition of functions notation, I have to take the sale price first, which is this one right here. So f of x. And after I apply the sale price, I'm going to be using the coupon discount. So we're going to be applying g of x after that. So essentially, all we're doing is we're taking f of x, right, which is 0.8x, and we're plugging that in right here for x. So my final equation would be, I'll just call this g of f of x. That's equal to, well, if I plug in right here 0.8x, that would be 0.8x, and then minus 10. So this would give you the price of the item after you take off the 20%. So you're paying 80% of that. And then you're also subtracting the $10 coupon.